let's take it one step further, and we are verifying trig identities, which means the left-hand side is equal to the right-hand side. Somehow we have to verify that. So to start, you need to make sure that the left-hand side is equal to the right-hand side, as there's an S missing. And a little bit of advice, you always want to start with the side that looks more complicated, because that way you have something to work with, and you can hopefully show that this side is equal to the other side. So if I look at this problem, the right-hand side looks more complicated than the left-hand side. So I'm working on the right-hand side and trying to show that the right-hand side is equal to the left-hand side. Now, which means here we have to find the least common denominator, which in this case is 1 plus cosine x times 1 minus cosine x. So I'm multiplying this one by 1 minus cosine x, 1 minus cosine x. Okay, let's see what happens. So strictly, you have to work on one side. You cannot say, oh, let me work on this side first and then on the left-hand side, and somehow being all discombobulated. It has to be one side only. You make a decision which one you want to show is equal to the other one. So I picked the right-hand side. I need to show that this is equal to 2 cosecant squared. My denominator is 1 minus cosine x times 1 plus cosine x. Now in the numerator, if I write it out, I have 1 plus cosine x plus 1 minus cosine x. Okay, let's see if we can now combine like terms in the numerator. You can see that the cosine cancel each other out, and what we have in the numerator is a 2. Now in the denominator, if I go ahead, this is the factoring of a difference of 2 squares. If you go ahead and you multiply this out, you get 1, and then a plus cosine x and a minus cosine x, they cancel each other out, and then minus cosine squared x. Now we have to use some of our fundamental Pythagorean identities here. 1 minus cosine squared x, we already know that is sine squared of x. So that becomes 2 over sine squared of x. And we all know that the reciprocal, if I have 1 over sine squared or 1 over sine, that is equal to the cosecant of x. So here we go, we're almost done. So we rewrite that into 2 cosecant squared x, and guess what? The left-hand side is now equal to the right-hand side, and I have just verified my first trig identity. Beautiful. Check mark. Here you go. Let's go to the next one. Cotangent x over secant x is equal to cosecant x minus sine of x. Okay, let's take a look. The left-hand side, we need to verify that it is equal to the right-hand side. Now, in this case, I'm going to start with the right-hand side again and see if I can change it into the left-hand side. The cosecant I can rewrite as 1 over sine of x minus sine of x. Now let me write that over 1. So here I have a fraction, the same spiel like we had before. We need to have same denominator, so the 1 has to be multiplied by sine of x. Okay, let's see what happens here. We get 1 minus sine squared of x all over sine of x. Okay, now always keep kind of an eye on the left-hand side and think, how do I change this now? Well, 1 minus sine squared, we know that is cosine squared. of x over sine squared of x. Oh, not squared, it's just sine. Okay, now I'm almost there. Why don't I change that into cosine x over sine of x times, then I still have another cosine of x. So I separate the cosine squared into cosine cosine. Now, the cosine x over the sine of x is what? The cotangent of x. Okay, we're getting there. Now, times the cosine of x. But this says over secant. So what I'm doing next is to make it look like I need the left-hand side. Instead of cosine of x, another basic fundamental identity, the cosine of x is 1 over secant of x. So if I rewrite it into cotangent x times, I hope I have enough room, times 1 over secant of x, and of course the cotangent is over 1. Now you just multiply your numerator. Let me just write it here. You can see I have just proved that it is equal to the left-hand side. Cotangent of x divided by secant of x, which of course is equal to the left-hand side. Done we are.